So this note section is going to be on acceleration, and acceleration is defined as the rate that velocity changes over time. And we've already looked at velocity, so now we can say, how does velocity change over time? Now, when we talk about acceleration, we can talk about its change in speed or its change in direction. So we can have either a positive or a negative acceleration. A positive acceleration means something is speeding up. So therefore, the final velocity, which we're going to write as VF, is larger than the initial velocity, which is VI, and our slope will be a positive slope. Negative acceleration is the opposite, so we are slowing down. That means the final velocity, which is VF, is smaller than the initial velocity, VI, and my slope is negative. So acceleration has a formula, VF, which is the final velocity, minus VI, which is the initial velocity, and this is divided by time. Now, this is not an equation you need to memorize because it is the second equation on your reference tables where A is acceleration, and we've already defined that V is velocity, T is time, and again, remember that triangle means a change in. So let's do some practice problems. First, we need to create our triangle. Final minus initial velocity is on top, being divided by time. So let's go ahead and make that division within our triangle possible. So final minus initial velocity divided by time, and what's left over is acceleration, which is A. So let's do some practice. A roller coaster starts down a hill at 10 meters per second. 3 seconds later, its speed is 32 meters per second. What is the roller coaster's acceleration? So if it starts at 10, that is the initial velocity. If it ends at 32, that is the final velocity. So 32 minus 10 meters per second divided by time, and the time here is 3 seconds. All right, so we're finding acceleration. So I've set it up, final minus initial divided by time. So 32 minus 10 is 22. And 22 divided by 3 is 7.3. And what are my units here? Meters divided by second. Another way to write this would be meters divided by seconds. And then I have another seconds on bottom. So that is times 1 over seconds. So my final unit is meter divided by second times second is seconds squared. So velocity has a unit of distance divided by time. Acceleration will have a unit of a distance divided by some time squared. There's your distinguishing factor. All right, how long will it take a car traveling 30 meters per second to come to a stop if its acceleration is negative 3 meters per second squared? Now, this is a negative number, so this is a negative acceleration. My slope is negative. I am slowing down. So I want to know how long the time. So how am I going to solve for time? I cover it up, and that's going to be final minus initial velocity divided by acceleration. So my final velocity here is I come to a stop. So if I'm not moving anymore, I have a velocity of 0. I was initially traveling 30 meters per second, and I am dividing by acceleration. My acceleration is a negative 3 meters per second squared. So 0 minus 30 is a negative 30 divided by my negative 3 meters per second squared. All right, so meters per second and meters per second cancel, leaving me with 1 second left, and that makes sense because time in this case is being measured in seconds. Negative 30 divided by negative 3 is 10, and we determined our unit is S for seconds. All right, so let's take a look at this in terms of a graph, just like we looked at velocity in terms of a graph. So let's do a quick review. Velocity, this is a velocity graph. And I know that because velocity is distance divided by time. Now, when my distance divided by time is not a straight line, it is a curve, that shows acceleration. So acceleration is indicated by a curve on a distance versus time graph. A changing slope means we have a changing velocity, and therefore we have acceleration. Now, acceleration in this case is positive, so this object is speeding up. But what if I wanted to take the velocity and I wanted to compare the velocity to a time graph? And in this case, we no longer have curved lines. We have lines with slopes that we can find. And this makes sense because we know velocity divided by time. We just saw that that gives us acceleration, and we did some practice problems. All right, so on an acceleration graph, the slope will give us the acceleration. A positive slope means that we are speeding up. A negative slope means we are slowing down. A straight line means we have a constant acceleration. And if the line is flat, that means we have no acceleration. And so in this case, we have a constant velocity. So let's take these ideas that we just wrote down and let's look at a graph and see if we can't answer some questions about the graph based upon what we know about slope of a velocity versus time graph. Specify the time period when the object was slowing down. So that is a negative slope. So if we look here from this point to this point, I have a negative acceleration, or I'm sorry, negative slope. I am slowing down. So this is going to be 5 seconds to 10 seconds. What point am I speeding up? So at 0 time to 2 seconds, and then all the way up here to 3 seconds, these are both positive slopes. So I am speeding up from 0 all the way to 3 seconds. Now my speed does change, okay? We can tell that from our slope, or my acceleration, excuse me. My acceleration does change, and I can see that from the slope, but I am still speeding up overall. All right, when am I moving at a constant speed? So here we have to look at where our line, check out this line. So my speed is about 2.5. At 3 seconds, my speed is 2.5. And at 5 seconds, my speed is still 2.5. So at this point on the graph, from 3 seconds to 5 seconds, I am moving at a constant speed of 2.5 meters per second. And at what point am I not moving? At time 0, my speed is 0. And at time 10, my speed is also 0. So a lot of things we can determine about a distance versus time graph, a speed versus time graph, all right, both in terms of acceleration. If it is a distance versus time graph in terms of acceleration, you will see it's a curved line. Remember from a previous lesson, a distance versus time graph, if it was a straight line, it meant constant velocity. If it is a curved line, it now means we have acceleration. If we look at speed versus time, the slope gives us the acceleration. A positive slope means we are speeding up. We're speeding up. And a negative slope means we are slowing down. One final thing, and this is a free fall. All right, and we're going to kind of talk more about this in our next unit when we talk about forces. All right, but a free fall happens when an object is accelerated down to the ground on Earth by gravity. And we know that gravity keeps everything on the ground. A positive is going to move toward the surface. A negative moves away from the surface. All right, so if I was to hold up my pencil here and I was to drop my pencil went toward the surface of the earth. That was a positive. Now, plants have negative because plants grow upward towards the sun. They move away from the surface, so they'd be an example of a negative. And here's some number that you need to know. All right, the acceleration due to gravity is always 9.8 meters per second squared. And this is very, very important. This is a very important number. In our practice problems, I may tell you an object falls towards Earth, but I don't give you acceleration. That is because it will be 9.8 meters per second squared. Ms. Colson, this is a lot of information for me to learn, and you are correct. It is a lot of information, but check this out, my friends. On your reference table, acceleration due to gravity is 9.8, and meters/second is another way to write meters per second squared. So two ways that you may see the units for acceleration. So this number is already provided for you on your reference tables. So your reference tables in this particular section of physical science is going to be your best friend.